Good. I'll take question 1. Your name, your job title, and position. My name is Henrik, or Henrik in English. My job title is postdoctoral research assistant, or postdoc for short. At Oxford University, and I'm a physicist. Right. Question 2. What is a quantum material? A quantum material is a material that we cannot explain without using quantum theory. That's the short answer. In my specific case, that often means magnetism, because magnetism is an entirely quantum mechanical effect. It doesn't exist without quantum mechanics. So to me, it's almost the same as saying something with magnets in it, or something with interesting types of magnetism. There are many other types of quantum materials, but I won't go into all of them. Question 3. Can you summarize your research in one sentence? I can try. I research, well, the cheeky answer is I research quantum materials, but that doesn't tell you much. I would say I will go back to the answer I just gave about magnetism. I would say I research exotic magnetism. Why do you do this research? I've always found it fascinating. It started out as when I was a PhD. Well, basically when I was quite young, I always knew I wanted to do something with math, and then I realized that physics is basically applied math. So it's actually something that you can have a physical problem, you can hold it in your hand and see it and investigate and look at it, I think that's really interesting. Magnetism specifically, there's a lot of really interesting problems, and it has behavior that's very exotic and different from what we see in everyday life, and I think that's fascinating. I like solving puzzles, and there's a lot of puzzles. Yeah, and also, so that's sort of on a personal level. There's also interesting because there's some challenges in the world that we need to address. For instance, with energy and new materials. And the research that I do is very much about trying to understand why materials behave the way they do. And we can only really get to use materials to the limit if we know why they do what they do. So that's also part of why I do this. Question 5. What's the best part of your job? That's definitely when you manage to solve a puzzle that you've been working on for a long time. When you get that eureka moment, you realize, I got it, I have this I finally can explain why this material does what it does, or I finally got this interesting data that can help me explain or sort of understand more about the material. It's when you get these moments of clarity, and suddenly you get this increased understanding of something. How did you get to where you are now? I did my. I've always been interested in math, and then I went to the Math Olympiad, which was really fun, and then after that the Physics Olympiad, because I couldn't get enough of these Olympiads, and then I realized everything I liked about math was actually physics. So I started doing physics in Denmark, where I'm from. Did a project with my what became my PhD supervisor eventually. Did a project with him for my bachelor thesis, and then for my master's thesis, and then I did a PhD with him. And then I saw a job advert for a postdoc position in quantum materials in Oxford, and I applied, and I got it. So that's how I ended up here. And I've been here for 2.5 years. What do you like to do outside of work? Dancing. I do a lot of dancing right now. A style called modern jive, which is a lot of fun. I also do some acrobatics, which is also very fun. I don't do a lot of the acrobatics myself. I mostly just lift my dancing partner in various interesting ways, which is good fun, and it's also it's good contrast to physics, where you're very much in your head, and you sit down at your desk and you work, you stare at your computer, and then afterwards going out and turn your brain off a bit, and then use your body to move around and get to meet people that are not physicists. I think is quite fun. Finally, what one invention or discovery would you like to see in your lifetime? Room temperature superconductors would be really, really cool. So superconductors, they are special because they can conduct electricity without any resistance at all. And that's quite unique, where, say, you charge your phone, then the phone gets warm. That's because of electric resistance. In superconductors, they don't have that. And they have a lot of really interesting properties. They can generate very high magnetic fields, and they respond in interesting ways to magnetic fields. There are many videos on YouTube if you search for levitating superconductors, for instance. There's some really cool stuff there. And they only work at very, very low temperatures. But there are hints that it might be possible to make them work at room temperature, and that would probably revolutionize the world in many ways. And I think it's quite ambitious. We've been working on these materials for 30 years, and we still don't quite understand how they work. But hopefully, within my lifetime, we can get some room temperature superconductors. That would be cool. That's part of what I'm trying to do. Yeah, that's everything.